Hello, and welcome to another Hot Metal Fab YouTube video. This is the promise video, the one I've been teasing for a while. It's going to be going over how we draw stuff. And hopefully by the end of this video, you guys have a basic understanding of the program that we use, how to use it, a couple of tips and tricks, and I hope you guys end up looking forward to the next video where we go over some of the more complicated stuff, such as getting stuff bent in the press brake, or more reference geometry, hole placement, things like that, and so on and so forth. So what we're going to do to start out with is just a quick overview of the program that we use. This program is called Omax Layout or Protomax Layout, and it's actually a waterjet program designed to both create cut paths and qualities and entities. We can see here we have the qualities available to us, one of those being 1 through 5 as the etch and lead in and out. What we're concerned with, though, because we don't run a waterjet, is just traverse. Traverse is basically going to output into a DXF file. Everything that is a traverse quality is going to output to that drawing exchange format file type, which will be the input into our CAM software. The CAM software that we use is called SheetCam, but certain plasma cutters have their own proprietary, such as FlashCut, or Torchmate has their own CAM software if you're using a Lincoln plasma cutting table, and so on and so forth. So what we use is SheetCam, and we'll go over that in another video. For now, we're just going to be dealing with Omax layouts, making sure that we use traverse for everything, which is the default quality to be cutting with anyways. So we're going to get rid of this, and we're going to start new. No, I do not want to save that. That was just our welcome image, and we're going to go over a couple of the features. So we can create a box by clicking on the box. Now everything that is over here has keyboard shortcuts. So B for box, L for line, C for circle. Shapes is a combination key, but we don't need to get into shapes right now. We can go over that a little bit later on, or maybe another video. We're going to make a fence base plate, though, and this base plate we're going to be able to screw into the ground, and we'll be able to set our fence post on top of it, and we'll be able to set many of these down on the ground. So we have fence panels that just screw down. We can fabricate them in the shop, take them out into the field, and just screw them down, and we have a nice contiguous fence. So to do that, we're going to draw a square. Okay, there's our square. Well, I just clicked twice and just kind of arbitrarily set up a square. I have no idea what size the square is. It's not square actually at all. It's actually a rectangle. To find out what it is, we're going to go down here at the bottom. We're going to inquire on one of these entities or these lines, and just click on it, and we're near it, and it's going to give me the length of 10.2. Well, that's not very helpful, and neither is this length of 5.9. All right, well, that's fine. Well, we can get rid of that. Control Z, goodbye. Let's create a box with some constraints. Let's create a box by clicking on it, and I want this box to start at the 0 point. To do that, I'm going to click 0, and it's going to start at the 0 point. And I'm actually going to constrain the size of the box too. Let's set it to 5 by 5. And we're hit OK, and we've got our nice, neat box. We're going to center that there, and it's perfect. And we can inquire again to make sure everything's right. We got 5 here, 5 there, 5 here, 5 there. Looks great. The other way we can measure stuff, which sometimes you need to do if you can't just inquire on a line, if you want to measure something across an entity that doesn't actually exist yet. So if I wanted to measure the distance between this corner and that corner, I actually need to use the measure tool, which is right next to the inquire tool. So we're going to measure from the end of this corner to the end of that corner. And if you were awake in geometry class, Pythagorean theorem would also tell you the same answer, which is 7.07106781118, so whatever. Don't really need to know that. Doesn't matter. All of our edges are 5 inches, and that's going to make a nice, neat 5-inch by 5-inch base plate. Moving on, we want to create some circles. To do that, we're going to click circle and make a circle. Okay, cool. Let's make another circle. And how about another one? So we get 4. How about 4? Okay, cool. Well, that's ugly. Well, that's not very much use to us, especially in the field. This one doesn't even, these two aren't even inside the square. Let's get rid of those. Let's do this the right way. To get our circles to be actually in the center of where we want it to be, square, if we want a square hole pattern, what we need to do is create reference geometry. So to do that, I'm going to create another square. And this one I'm just going to draw an open space. I could draw it, let's just draw it here. So I pressed B on the keyboard for the box tool. I'm going to click, create a box that I want to be 4 by 4. That way our circle pattern ends up to be 4x4. To get those circles, I'm going to click on the circle tool, and I'm going to click end to snap the center of that circle to be at this corner. We're going to draw this for, let's just say 3/8 hardware. So let's upsize it to 0.4, so there's a little bit of leeway. The decimal equivalent of 3/8 fractional to decimal is 0.375. But we're going to upsize it so there's a little bit of leeway. If you're using a plasma cutter, you need to upsize it anyways. The plasma cutter cuts a little bit off dimensions. Sometimes the circles, the holes aren't exactly they're not very circular. So we're going to upsize it a little bit. If you're cutting with a laser cutter, do this anyways. That way you have a little bit of play. The washer that you use and for this hardware anyways is going to cover the hole up anyways. So just upsize it to 0.4 or 0.45, or let's just say if you're using 1/2 inch hardware, cut it at 0.55, whatever you want. For now, let's just do 0.4. So we set that diameter in there. We're going to hit OK, and we've got that there. For the rest of these, I'm going to use the keyboard tools and watch how fast it goes if you're not clicking. So I'm going to hit C and then E and then click and then hit enter. The program remembers the last diameter or radius that I used. So it set all of these to 0.4. To verify that, we can inquire on one of the arcs, and we get our diameter of 0.4. It ends up being 0.39, repeating. Not sure why it shows up like that. Close enough, good enough for the girls I hang out with. How do we get this square into there? Well, it's simple. We're going to create reference geometry. We're going to get into the line tool now. So the line tool works the same way as the box tool. You click it, and you can click anywhere in space in 2 different points, and it creates a line. Very cool, very dandy. Not good enough. We need to create a line that is at the middle of this to the middle of the other side to intersect this square directly in half, essentially. We're going to do the same thing here, but we're going to use the keyboard shortcuts of L and then M to tell the program that I want to start a line from the middle of this line. Let's do perpendicular. We'll do a line perpendicular referencing this line, and we get the same result. Now, what we're going to do is we're going to use the select tool. We'll click it for now. We're going to right click this one actually. We're going to select the window tool. We're going to create a window using 2 points. Click there, click here. We've selected everything here. We'll use the move tool over here on the left. We're going to move using the same snap tools from the middle of this line to the middle of the other reference geometry line that we created. We'll click, it drops it. All we have to do now is get rid of all of this reference geometry. To do that, it's not here, but we're going to press E on the keyboard, and that's going to change the cursor to the erase tool, and it's going to start deleting everything that we don't want, because we don't want any of this reference geometry in the final base plate. And there we go. We still have our holes selected. We need to unselect those so we don't accidentally delete those in the future. To do that, we're going to right click the deselect tool. We're going to deselect all. Or alternatively, we could deselect, we could just click it, we get the deselect cursor. You can see the little minus sign next to the cursor, meaning we're about to deselect everything that we click. This is a time consuming and kind of very clunky way to actually deselect everything. So if I want to reselect everything that I had, select all. I could deselect just the box by pressing D and C for deselecting connected, and I deselect that, blah, 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 whatever. The deselect menu, when you right click on it, has so many different selections. Same thing with the select tool. It's all the same, but you either select or deselect, whatever. So let's center back here, and we're home base. Good to go. Let's fancy this bracket up a little bit. Let's get a fillet going on these corners. Let's round them off a little bit. To do that, we'll click the fillet tool, or F on the keyboard brings us to that. 0.375 is about what we want, and the reason for that is it's contiguous with the diameter of the holes that we've set. We've set these for 3/8 hardware, and just to keep consistent, we'll do a 3/8 fillet on all of the corners. We could do 0.25 too. It doesn't really matter. Let's just do 0.25. To use the fillet tool, we'll click on the 2 entities that we want filleted together. So we'll click here, and we've got a fillet. Click, 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 and click, click. The other tool that you can use to fancy up 2 different entities that intersect or join each other is the chamfer tool. So we'll get rid of all of those fillets, and we'll chamfer everything, and we'll do a 0.375 or a 3/8 chamfer on everything by doing the exact same thing by clicking, clicking, click, 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 tap, tap, and there we go. Everything is fine and dandy. It's exact. You would do this if you wanted like weld clearance, if this was a bracket being welded to in a T joint to another bracket. But in this case, we want this fence post base plate to look kind of neat, so we'll fill it at 0.25. Click, click, click all those corners. We've got a nice fillet going on. So we need to be able to let the fabricator have an easier time when he's working with these. So we're actually going to place our fence post here inside of here. Well, how to do that is the exact same way as we set the reference geometry for the holes. So we could do that, create a box, L, M, click, M, click again, line to the middle of, S, W, select the window, move from the middle of that to the middle of that, and there we go. Get rid of those entities. D, A for deselect all, and there we go. That was quick and easy, so let's back it up quite a bit, and let's actually do this correctly. Now, some not so smart guy put one of these base plates right up against the wall, right? Or you know that you need to end up putting this fence base plate right up against the wall. If the fence post was right up against, right in the center, you'd have a hard time welding all the way around it. I know I would. I mean, depending on what it was. But this is an arbitrary situation that we're just creating just for the sake of getting a little bit more explanation on how this program works. So what we're going to do is we're going to actually offset the fence posts off of the edge here. We have an entity that's left over from when we drew that middle line, that middle reference geometry line. We're actually going to use that to our advantage. We know that that line is in the exact center of the base plate even after we filleted it. So let's just say we want an offset of 1.5 inches. So to do that, we're going to draw a line by clicking L or clicking line here from the end of this entity. We get a dialog box to specify the dimensions of that line. Using the degree wheel here up at the top, we know which degree measurement we need to input to get the line to go a certain direction. So in this case, I know that I want the line length to be 1.5 1.5 at 180 degrees to get it to go off to the left here. And I'll hit OK, and it creates that line for me. We're going to create another box. Let's just say we're using 1.5 tubing for our fence post. So we're going to create another box using the same constraints that we did earlier by typing in 1.5 and 1.5 for the width and the height. Hit OK. Create our reference geometry here by L, M, click to get our line to be in the middle of this square. We're going to select everything by pressing S on the keyboard, W on the keyboard to get select window. Select everything here. Move, we'll just click it here, and then we'll select middle here instead of putting it on the keyboard, and we'll hit end on the dialog box or E on the keyboard to get it to be on the end of that line. Delete our reference geometry, and now we have the placement here. Now this makes it so there's no guessing where this fence base plate goes. You plunk it right into that hole, and it's perfect. So now I'm quickly going to show off here. That took a while, but I'm going to show you guys how quickly this can be when you're setting something like this up. I don't know how long it's going to take me, actually. I'm going to guess less than 30 seconds to draw everything just as I drew it. And I'm just doing this. I say it's a show off, but it's really just to show you guys how quick and easy this program is. So let's go through that real quick. So circle box at 5, 5. There's that. I'm going to draw another box that is 4, 4. Circles at the end of each one of those at 0.4. Do that, that, and that. Line from the middle of that to the middle of that. Line from the middle of that and that. Select all. Move from the middle of that to the middle of that. Deselect all my reference geometry and get rid of all of that. Sometimes it intersects weird. Get rid of all that. Fillet that. 0.25. Cool, cool, cool. I need my line from the end of that, so I'm going to do 1.5 off at 180, right? Yep, 180. There we go. Create another box that is 1.5, 1.5. Create that. Line from the middle of that, And I need to be careful because I still have my circles selected. If I were to select this and move this from the middle of that, it grabs the circles as well. Don't want that. So I'm going to deselect window, or actually go back to where they were selected. I'm going to deselect window, get rid of those. This box is still selected. MM to middle, move that to the middle of this, to the end of this line, get rid of that. There we go. An exact copy. If I were to take all this, move it from the center of this circle, oops, move it from the center of this circle, center of that,
couldn't even tell. There's overlapping entities, but you know, we can get rid of that quite easily. So that didn't take very long at all. I wasn't counting. I'm just showing you guys how quickly it can be to work with this program for something as simple as a fence base plate. In the future, what we're going to do is go over more complicated things like putting brake lines, brake reliefs, how to account for the tooling that the press brake uses, especially if you're sending out the part or the file to be cut out and then bent by a place that you don't know their capabilities. We're going to account for that. We'll go over some more complicated geometries and XY positioning and placements. We'll make a bumper bracket coming up. I'm going to be building a bumper for a third generation 4Runner from 96 to 2002. So we'll make a bracket for that. So I'll show you how I measure it, how I go from the in real life measurements to a computer drawing and to actual cutout material. For now, I hope that this quick tutorial was good enough. I'm probably pretty bad at tutorials like this, but I'm hoping that you guys at least get an idea of how we do what we do and how simple this program can be. There's so many different tools to this program. Hopefully we'll go over all of them, including one like this, like the copy tool. So I'll select everything here. I know that my dimension is 5 by 5, so I'm going to copy this at a displacement copy line of 5.25, and I know that setting it like this means that there's going to be 0.25 spacing, so a 1/4 inch between each base plate. I'll hit OK. It's going to pop up an additional dialog box. I want 10 total, so 9 additional copies, and now I'm ready to cut out 10 of these, and I'm ready to make my base plate. I'd probably want to center the square for the rest of these because this is the only one that was up against the wall, just as an example, but super easy. Or I can select everything. I can mirror everything on the y-axis using this entity right here, move everything 0.25 at 90, and there we go. We've got 2 rows of base plates in case I'm making a super long fence. This is just showing off what this program is capable of. I think it's incredibly powerful. It's free. I'm going to leave a link in the description for the download for this program. I think that everyone can use it. It's very simple. Anyone can learn it. And I hope that this video and the future ones in this series empower you guys to be able to make your own parts and send them out. Or maybe you've got your own plasma cutter and you're able to mess around with things. We'll do an artwork video. We'll do, again, the bumper brackets coming up. We'll do artwork, signage, how to render things, how to, design and measure, all kinds of things. There's so many things that I want to be able to show you guys so that you guys can make your own parts, brackets, fixtures, whatever you want. For now, thank you for watching another Hot Metal Fab YouTube video. We'll see you guys in the next one.